Look closely at the water displacement and light refraction here. Generating those complex physics simulations with precise textures required massive computational power. By early 2026, producing silent, hyper-detailed clips like this was the industry standard for raw visual fidelity. Then, in April 2026, OpenAI permanently shut down the Sora web application and completely discontinued its API. Operating that model cost an estimated $1 million a day. The sheer volume of server hardware required to process billions of parameters for every frame made the scale of generation financially unsustainable. Simultaneously, major studios and copyright holders mounted aggressive legal challenges against the training data used to build the model, making its commercial scaling perilous. These extreme operating costs and legal hurdles created a power vacuum. While the leading general-purpose model went offline, its competitors survived by narrowing their focus, evolving into tools designed for specific utility rather than raw, unoptimized photorealism. Google DeepMind captured the high-end enterprise market with Veo 3.1 by making true 4K resolution sustainable for corporate production pipelines. This diagram shows how Veo 3.1 solves post-production audio. The model generates 48 kHz synchronized dialogue, sound effects, and ambient environmental audio at exactly the same time it renders the visual frames. That simultaneous generation reduces a workflow that once took 40 minutes of manual audio syncing into a single 4-minute pass. Runway took a different route with Gen 4.5. They prioritize tools that give directors precise control over camera movement and spatial geometry over simple text prompts. Using in-video text editing and AI-driven motion capture, filmmakers can move a single character through distinct lighting setups and environments while keeping their face, clothing, and proportions perfectly intact. Google and Runway secured their market share by integrating directly into established Hollywood pipelines, functioning as post-production utilities embedded within the studio system. Meanwhile, social media marketers required speed. xAI built the Grok Imagine engine to render cinematic frame rates in under 20 seconds. Grok 4.3 paired that speed with the ability to ingest raw video clips alongside massive text documents, allowing the model to mathematically reason across both formats simultaneously. Across the globe, Kuaishou deployed Kling 3.0, backing it with massive corporate server clusters to push the limits of render times and physical simulation. Kling solves typical temporal decay by chaining 10-second outputs into seamless 3-minute continuous sequences at 60 frames per second, allowing heavy fabrics and fluids to move without visual stutter. While some built refined studio editing suites, Grok and Kling built automated high-velocity content engines engineered for raw scale. For highly specific workflows, ByteDance introduced CDance 2.0 to operate as an extreme multimodal compositor. This diagram illustrates its architectural advantage. The model can ingest up to 12 different reference files, like character images, audio tracks, and environmental photos, and synthesize them into a single cohesive output. On the complete opposite end of the spectrum, open-source models like LTX prioritize rendering faster than real-time, allowing developers to prototype locally on consumer hardware without paying API fees. The market fractured into these specific niches because no single architecture could efficiently balance Hollywood-grade rendering, real-time generation speeds, and massive multimodal ingestion. By the end of 2026, the AI video landscape is defined by extreme fragmentation, with different models owning distinct segments of the production cycle. The sudden shutdown of Sora forced enterprise technology officers to reevaluate their reliance on a single vendor's experimental research. Organizations now prioritize durable, deeply integrated software ecosystems that won't disappear when computation costs run high. These models function as specialized reality engines, synthesizing native audio and consistent physics directly into the video stream.